In this video, I'm going to demonstrate Newton's third law. So I'm going to show you how to set this up. We've got some nice cylindrical smooth pencils, which are going to act as frictionless surface. Please mind my dog there on the corner. So I'm going to set this up and place, when we're ready, we're going to place another card on top. And all this does is basically create a frictionless panel. Now I'm going to place my remote controlled car on top of the card. And then we're going to move the car forward using the remote control. So as you can see, body A, let's call that the car, moves forward. Body B, which is the card, moves in the opposite direction. You can use force vectors to demonstrate what the forces acting look like on each of the bodies. Please mind the dog. Okay, so that's the force acting on the card, and this is the force acting on the car. Now you can clearly see that those forces never cancel out because they're acting on two different bodies. They're equal in size and they act opposite directions on two different bodies. Now what we're going to do is I'm going to set it up again, and when I've set this up, I'm going to place a more massive object instead of the card on top of the rollers. So a nice thick physics book, which is more massive than the car. It has more mass. And we're going to place the car back on top, and I'm going to repeat it again. So you may want to pause the video here and guess what happens. So let's have a go. There we go. So you can see that the car moves forward. So there's a force clearly acting on the car. Okay. And the book moves back. But how big is that force on the book? Well, it's basically exactly the same size because it's a Newton 3 pair force, right? But why is it that the book doesn't accelerate as much as the car? And that's because the forces acting on the car and the card and the book, are exactly the same size, but because now the book is much heavier or more massive, it's not going to move very far. Okay, so it's not going to accelerate as a consequence of Newton's second law.